Okay, so in today's video, I'm going to show you how to create a simple project using the Microbit board together with the 16:2 character display, and I will show you how to show three different things. So the first thing is the sound level, and you can see how it's changing as I talk. So it goes from 0 to 100%. The next thing is measuring is the temperature. Right now it's showing 26, but I don't think that I have 26 degrees Celsius in here. It's most likely that the sun was shining on the board and it's getting a little bit harder than it needs to be. And the last thing is the light sensor. So it's measuring how much light it's shining on the board. You can see that as I cover this board with my hand, it goes back to 0% and then to the original value. Before we start, I want to talk about the sponsor of this video, which is a PCBWay, and they offer quite a lot of useful, cheap and quick services. For example, PCB prototyping, PCB assembly, advanced PCBs, 3D printing, CNC machining, SMD stencils and much more. If you use the link below this video, you can get 10 PCBs for free, only paying for shipping, which I think is a great deal. So again, thanks again for PCBWay. So let's get started. The first step is to go to the makecodemicrobit.org and create a new project, which I will name with some very long name, and hit create button. In here we have two different ways how to write our code. We can use JavaScript or we can use blocks. I will be using blocks today because it's much easier for beginners. So we have the predefined set of actions which you can access from this menu. We have our code on the right side and the simulator running on the left side. We want to get some values from the built-in sensors, and that's what the input menu is for. And we can get some very interesting values, like for example acceleration or maybe the combat setting. But today I'm interested in three different things. One is the light level, then I'm interested in the temperature, and finally in the sound level. Note that for the sound level you have to have the Microbit version 2. I want to print out those values, and eventually of course we will use the 16:2 character display, but for now let's start simple and just print it out somehow. And there are two different ways. We can use this 5x5 LED matrix to print stuff, so I can just go to the basic and select show string, and if I put it into OnStar it will just show me this hello string. The problem is that those characters are being shown one after each other, so it takes a lot of time and it's just, not very readable. The second way is to use the serial communication to send those values from the Microbit board into your PC and display it there. And from some version of the Chrome browser, you can actually show those values inside the browser. You don't even have to have some additional application installed. So to do that, you first establish the serial communication, so open the serial menu and select the serial redirect to USB. That will make sure that whatever you send from the Microbit will be sent to the USB, which means that it will be sent to your PC. And then we can just send some message. So inside the serial, we select serial write line and we will put it inside the forever loop. I can get rid of the show string hello because we don't really need it. And then I want to print out for example, the light level. However, I don't want to only print the value because it wouldn't be clear what's going on. So before printing this, I will just connect it with another piece of text. So I'll open the text menu and select the join, and here I will join label light together with the light level, and I will do the same thing for the sound and for the temperature. So here is sound, and instead of light level I will put in the sound level and the temperature. Again, instead of light level I will put in the temperature. I can get rid of those two nodes, and since this will be running pretty quick, I will put some kind of delay at the end, so I'll select pause maybe for half a second. You will notice that as the simulator restarts, we have now some additional controls. We have control for the volume, for the sound level, so I can use this slider to change the sound level from 0 to 255. I can also change the temperature from -5 all the way up to 50 degrees Celsius, and I can also control the light level, which is like the sun shining from top, so going from 0 on top to the 255 on the bottom. What I can do now is to click the show data from the simulator, and it will show me those values being printed out in this window, so I can see the temperature, light and sound, and at the same time I can actually see those graphs representing those values. So let me just make this window a little bit bigger so I can see all three graphs at the same time, and I have the graph for the light, for the sound and for the temperature, and I can use those controls to simulate a different sound level, a different temperature, as well as a different light level. So you can see the first one, light is changing as well. So it seems to be working perfectly fine inside the simulator. Let's see if we get the same result with the actual device. And there are two different ways how to upload the program, the sketch, onto the Microbit board. You can click the download button that will download you the file, the hex file, that you can just copy inside the Microbit folder, which is just a removable device. But there is also a better way, and that is to pair the USB device, the Microbit, together with the Chrome browser. You can see here I can just click pair now, and it will show me the details on how to do this. I have to actually select the board in the pop-up right now, so I'll select this one and say connect. And now it should be connected. So the next time I click the download button, it will not download me the file, but it will send it straight to the Microbit board, so I don't have to copy any files around, and that's quite convenient. Also, since now this is running on my Microbit board, I can select show data from the device, and I can see some real world values. So as I talk, the sound is changing, and the light level is quite low because there is dark in my room, and the temperature is around 24 degrees Celsius. So I have those real world values from the Microbit board. So the next step will be adding the 16:2 character display and showing those values on the display instead. And the display might, for example, look something like this. What's important to note is that it should include this small board, which is often called backpack, and that is used to convert the parallel communication into the I2C communication, which means that we only need 4 different pins to connect this to Microbit. So the ground, the VCC, the SDA, which is a serial data, and SCL, which is a serial clock. There is still one slight problem, and that is this display requires 5 volts, while the Microbit is only 3.3 volt logic. Now for the data communication for the SDA and SCL, this is actually fine, because while this is 5 volt logic, you only need about 2.5 volt to be recognized as logic 1, so 3.3 volts should be enough. However, for VCC we still need 5 volts. Thankfully there are many boards available for the Microbit that actually gets you 5 volts. For example, this one where you can actually switch between the 3.3 volt and 5 volt logic, or this one where you can provide additional USB connection and you can get this 5 volt for certain pins. The other option is of course to get the 16:2 character display that is made for 3.3 volt logic. So what I will do right now is to snap the Microbit into this board and then connect the display so the VCC goes to 5 volt, the ground goes to ground, and then I will connect the SDA to SDA and SCL to SCL. As for the actual pins, those are pins 19 and 20 on the Microbit. And here is how it looks like when everything is connected. You can see that for this particular board, I have a secondary USB connection that provides those 5 volts, and I of course have to have this switch connected in order to provide 5 volts for the display. We are not showing anything on the display yet, but most displays when connected to the power supply will show the first line as fully filled and the second line as empty, although it's a little bit hard to see in this case. Once you have the display connected, we want to install the corresponding library, and you do this by clicking the extensions and typing 1602, pressing the enter key, and there should be only one library available. So I will click this one and it will be downloaded and added to my project. And this is this one, Microbit, and underneath you can see LCD. So we have quite a few functions to working with the LCD display. As you can see here, we can connect to the display, we can show some string, we can clear the display, find out if the LCD is connected, create a special character which we can print, and finally there is a command for switching the LCD backlight on and off. Let's start by connecting to the display, and if I hover my mouse over this command, you will see that it says that the usual addresses are either 39 or 63. Now it's worth noting that those values are decimal values, so 39 corresponds to the 27 hex and 63 with the 3F of hex, because usually you define those addresses and the hexadecimal numbers. This is quite different. Here you use decimal numbers. So I'll drag this inside the onStart function, and you probably have to try both addresses because I have multiple displays and really one of them is using 39 and the other one is using 63. And I was thinking maybe there is this LCD is connected command, so I can say if the LCD is connected I will continue, if not I will use a different address. Unfortunately it doesn't work this way, so the LCD is connected will always return true if you first call this connect to LCD. Doesn't matter if the address is right or wrong, so I can just not use it. Let's start simple, and it is by showing some simple message, for example hello world. So I will open the LCD and select show some string at some position and put it into onStart, and let's just show some string, for example hello world. Could be on the first position and the length doesn't matter that much. If I hit the download button, it should be downloaded on my Microbit. Unfortunately right now I cannot see it on my emulator because I don't see this 16:2 character display, but it should be running fine on the actual display, so I can see the hello world. Again, if you don't see it, try changing the address to the R1 and see if that helps. Hopefully it will. Let's move on to showing some dynamic values. So I will put this inside the forever loop, and instead of showing the static text hello world, I will show the light level. So I'll just copy light level and put it inside the show string, and I want to show it somewhere around the end of the second line, so maybe position number 28. And again, the length doesn't really matter, maybe 4 digits should be fine. Let's talk about creating our special characters, because for example for the light level it might be a good idea to show some kind of shining sun or maybe a flashlight. So let's create a custom character that will look like that. I will open the LCD and select make character, and we can create up to 8 custom characters. For this we need to also drag in this character block inside here, and now it's just up to you to create your own pixel art. So I'll try to create something that looks like the flashlight, maybe like this. And once we have it created on the position number 1, we can use the show character function to show it on some position, and I want to show it as a first thing on the second line, so the position should be 17 in this case. And I want to also show some kind of string, so I will again drag in the show string and show the light at the position on the second line, maybe position 19 should be fine. Again, the length, I don't know, 6 maybe. And the last character will be the percentage sign, so I'll drag in one more and set the percentage sign that will be the last character on the second line, which is the position number 32. Let's try to upload it on the Microbit and see how it looks like. And we can control how much light is shining on the board, for example, by covering the front side of the board with your hand. Note that there is no dedicated light sensor on the board, but the LEDs itself are actually used to calculate the value. Also, you will notice that the number goes from 0 to 255, which is not quite a percentage value. So in our code, we need to convert from 0 to 255 into 0 to 100%. For that, let's create a new variable called gauge value. So inside variables, click the make a variable and call it gauge value, because later on we will also use this to display the gauge, and hit the OK button. And now we can get the access to setting the gauge value or changing it by some amount. We want to set it to some value, so I'll drag in the set gauge value to some value, and that value will be of course the light level, but instead of going from 0 to 255, it will go from 0 to 100, and for that we will use the map function. So I will drag in the map function, and we want to map the light level, which goes from 0 to 255, and we want to map it between 0 and 100. And of course, after we calculate it, we want to also show it. So instead of showing the light level, we will show our new variable gauge level, like so. And let's just try to download it on the Microbit to see how it looks like. And it should rightly show the percentage. It's not that bright in my room, so it doesn't go all the way to 100%, but only to some value. And I think it might be time to draw the actual gauge on the first line, so let's do that. Before we start with the calculations, we need few custom characters, actually at least two for the fully filled and fully empty character. So let's just create those. So Microbit LCD, create a new character, drag in the character box, change this character, for example, to value 2, and this might be the empty character, which might look, for example, like this. This is what I've used in my previous design, and let's just copy this, use it as character number 3, and this one will be fully filled, so I'll just drag in those lines as filled ones. For drawing the gauge, we want to go over every single character in the first line, so over those 16 characters, and calculate if we want to show the empty gauge or the filled gauge. For this, we of course need some kind of loop, so I'll open the loops and select this one, so for index from 0 to 4, so I'll drag it in here, but of course we don't want to go from 0 to 4, we want to go from 0 to 15, so we will cover all 16 characters. Unfortunately, we cannot go from 1 to 16, so we will have to have some additional calculations, because the position inside the LCD is mapped from 1 to 16 instead of 0 to 15. Let's add the if statement. So inside the logic, I will add the if statement, and we want to somehow compare the index with the gauge value. So again, I will insert the comparison, which might be, for example, this one. However, we have the same problem. So the index goes from 0 to 15, the gauge value goes from 0 to 100. So we want to, of course, map the index to 0 to 100 as well. So I'll insert the math map, and I will map the index. So I'll drag in the index inside here, which goes from 0 to 15. It should go from 0 to 100. I want to compare it together with the gauge value. So inside the variables, I will drag in the gauge value, and I want to say that if this remapped index is smaller than the gauge value, I want to show the filled gauge, which is the character number 3. So I'll select Microbit LCD and show the character number 3. So number 3. And the position should be the index plus 1. So we want to add a simple math expression, which might be, for example, this one. So the position will be the index, try to drag it inside like this, plus 1. And we'll actually copy this piece one more time, because if this is not true, so if the index is bigger, so if we are over the character that is actually being calculated as bigger than the gauge value, we want to show the empty gauge, which will be character number 2. And believe me or not, this is actually the whole code that is required to draw the gauge. So let's just try it on the Microbit. And we have a nice looking gauge that shows the percentage value. If I compare it to my original creation, I was actually drawing the lines on the first and the last character, so there is like the rectangle around the gauge. So let's try to do that as well. At this point, it shouldn't be a big surprise that we need few more custom characters. So I'll copy the empty one and maybe put it on the position of 4, because that's the one we still don't have set, and this will be the starting character, and just copy it one more time. It will be position number 5, and that will be the ending character. It might look something like this. So for the fully filled character, we don't need to actually do anything else, but if there is an empty character, we will look into the position, and if this is the first character, we will show this one, and if this is the last character, we will show this one. So I need one more if statement, so I will select logic and select the if statement that I will put it in here, and I will compare the index with the position. So I want to compare it. Inside logic, I will say the comparison, and I will say that if the index equals 0, I want to draw character number 4. So the character should be 4. Click this plus button to have an error statement. Say that if the index is 15, that's this last character, I want to show the character number 5. So the character number 5, and in all the other cases, I will show the character number 2. So else the character number 2. That should cover all the possible use cases. Let's download it on the Microbit and see how it looks like. And I think it looks better now, because even when the 0 is being shown, there is still the outline around the gauge, so you can see where it starts and where it ends. So at this point, the only thing left to do is to show also the other values, which is the sound level and the temperature. And in my original design, I've used those push buttons on the Microbit board to switch between different pages, so let's try to do that as well. Let's create a new variable called screen, and that will tell us which screen we are currently at. So click the OK button, and we have access to the screen. So in the on start, we want to of course set the screen to be 0. So let's set the screen to be 0, and we want to change it when we press the button. So I will open the input and say if the button A is being pressed, I want to change the variable of screen and actually change it by some value. So maybe, for example, by -1, I want to jump backwards when the A is being pressed, but I want to make sure that it will still be 0, 1 or 2 for our 3 screens. So I will select logic and say that if the value of screen is smaller than 0, I want to jump it back to 2. So set the variable screen to be 2. I want to also use the button B, so I'll copy and paste this block of logic, and you can see it's being grayed out because we cannot have the button A being pressed 2 times, but I want to change this to button B. I want to of course change it by 1 and make sure that if this is bigger than 2, it will jump back to 0. So the screen switching should be done, but we need to update our code inside a forever loop to show appropriate values. By the way, I probably don't need the pause anymore because I was pausing with just those serial lines. It was quite fast, but with drawing on the display, it's actually much slower, so I don't need any kind of additional delay. Let's get rid of this one. If we want to keep the same layout as we have for the light screen, we probably need 2 more additional characters, one for the sound level and one for the temperature. So let's just create those 2, and we should still have a little bit of characters left. So we have 5 out of 8. So the number 6 might be, for example, the volume. Could look like this, and number 7 might be the temperature, which could look like a small thermometer. Also for the temperature, it might be impossible to get the degree symbol, so let's just create this one as well, and I will also draw it together with the C character for the degrees Celsius. So this will be the last one, the character number 8, and that will be the degree symbol together with the letter C for the degrees Celsius. So we have used all the 8 special characters, but that's perfectly fine because we don't need more of those. Let's jump back into the forever loop and do the screen switching. Let's add a new if statement and say that if the screen is 0, we want to show the light level. If the screen is 1, we want to show the sound level. And if the screen is 2, we want to show the temperature. So let's just add a new logic, a comparison of the screen. So variable screen, this one, put it inside. And if the screen is 0, we will show the light level. So I'll copy, or actually not copy, but move some of the pieces. And you see that as I move this set, it will also move everything below this one. So I have to actually press the Control key on my keyboard to only move this one line of logic inside this piece. So I want to set the gauge value based on the light level, and I want to print all those light level related values on the display. I don't need to move the gauge drawing because since we will be always updating the gauge value, we can actually keep the gauge drawing the same for all 3 screens. So I will only click this plus button to add a new if statement, and I will again add a comparison, and I again compare the screen variable and say if the screen is 1, now I want to show the sound level. For this, I will copy all those 5 lines of logic, so setting the gauge value and printing out some things. But this time I don't want to map the light level, I want to actually map the sound level, so I'll copy the sound level inside here. I want to print out the text sound and show the special character, the first one, which will be the sound symbol, which is a special character number 6. So special character number 6, and everything else should stay the same. And the last if statement will compare the screen to the value of 2, so I'll copy this piece and say if the screen is 2, I don't want to actually map the value of temperature, I'll only say set the gauge value to be actually the temperature. So I'll delete this map and only set it to temperature. So I'll copy paste the temperature and put it in here. So it will directly set the gauge value to be the temperature, which of course means that the temperature will be showing on the gauge as from 0 to 100 degrees Celsius, which might not be the best way to do it, but it will be the simplest way how to do it. And then I will copy those 5 lines of logic to show all the other elements. Like so, with the change that the sound will say temp as temperature, and the first special character will be the temperature symbol, which is symbol number 7. So character number 7, and instead of showing the percentage sign, I want to show the degree sign together with the C for the Celsius. So instead of showing this percentage, I will actually copy this piece and show the character number 8. But of course the position will be the last character on the second line, position number 32. there is no reason to have this else in here, so I can just click this minus button to get rid of this one. And there's this light level which is just hanging around. I can delete this one. If I zoom out, I should probably see everything as it should be. So if the screen is 0, we will show the light level. If the screen is 1, we will show the sound level. And finally, if the screen is 2, we will show the temperature, and the switching will be done with buttons A and B on the Microbit board. Let's download it on the Microbit board and just see if everything works as expected. So by pressing the buttons A and B on the Microbit board, I can switch between individual screens for the light level, the sound level and the temperature. And of course the sound is changing as I talk, the temperature is staying pretty much the same, and the light level again is measuring from the built-in LEDs. As I cover the front page of the board with my hand, it's going down to 0 and then back to the original value. So in a little over 20 minutes we were able to create this pretty complex design, and I think it's pretty cool because we didn't write a single line of code, we were just dragging those logic blocks around. And what I like about the Microbit the most, it has all those built-in sensors, so can get really interesting data without too much effort. And perhaps in my future videos I might use the error sensors as well. That said, this is all for now. Thank you very much for watching. If you have any questions, please put those down in the comment section. If there is some type of content you would like to see on my channel, please let me know as well. Again, thank you very much for watching, and I hope to see you next time. Thanks and bye.